Hi children, welcome to chemistry class. So in the last class we discussed about electronegativity. Today we are going to learn some important and the last concept of this chapter. You know, atoms attain stability in chemical bonding by either transferring or sharing electrons. Today we will discuss about how to find the valency of elements and how to write the chemical formula of elements using valency. So let's start the class. In sodium oxide, two sodium atoms donate one electron each to the oxygen atom and becomes Na plus, O2 minus and Na plus. Let's analyze the formation of hydrogen chloride and carbon tetrachloride. In hydrogen chloride, hydrogen and chlorine share a pair of electrons with each other. And in carbon tetrachloride, 4 chlorine atoms share 1 electron with a carbon atom. So from these compounds you will get an idea about the number of electrons transferred or shared between these atoms. The number of electrons lost, gained or shared by an atom during chemical reaction is its valency. Let's have a clear idea about valency of some elements. First one is sodium oxide. You know sodium donate 1 electron and oxygen accept 2 electrons from 2 sodium atoms. So the valency of sodium is 1 and that of oxygen is 2. In hydrogen chloride, both hydrogen and chlorine share 1 electron with each other, so their valencies are 1. Similarly, in carbon tetrachloride, carbon share 4 electrons with the 4 chlorine atom and chlorine share 1 electron with the carbon atom. So its valencies are 4 and 1 respectively. There is an activity given in your textbook, so complete the table and write down the valencies of missing elements. Next, we will learn how to write the chemical formula from valency. So what do you mean by a chemical formula? It is a method of indicating the number of atoms in a molecule using symbols. Imagine that magnesium and chlorine combine together. You know the magnesium, its atomic number is 12. So the electron configuration will be 282 and the number of electrons donated by the magnesium is 2. In chlorine, the electronic configuration will be 287. So the number of electrons received by the chlorine atom is 1. Now tell me, how many chlorine atoms are required to receive the electrons donated by the magnesium? Yes, 2 chlorine atoms, right? Then there will be 1 magnesium atom and 2 chlorine atoms in a molecule of magnesium chloride. Hence, the chemical formula of magnesium chloride will be MgCl2. Now look at another example. Aluminium. Its atomic number is 13. So the configuration can be written as 283. And the number of electrons donated by the aluminium is 3. And in fluorine, its atomic number is 9. So the configuration can be written as 27. So the number of electrons received by the fluorine atom is 1. In this compound, 1 fluorine atom receives 1 electron from aluminium. So it requires 3 fluorine atoms to receive 3 electrons from aluminium. So the chemical formula of aluminium fluoride is AlF3. Now let's discuss about another way of writing chemical formula using valency. There are certain rules. First one, write the symbols of elements in a compound in such a way that the symbol of element having lesser electronegativity comes first. It means atoms with the electropositive nature comes first. Rule 2. Write the corresponding valencies of elements and write them as subscripts. Third one, interchange their valencies. And fourth rule, reduce to the simplest ratio if necessary and write the chemical formula. Look at the example of writing the chemical formula of aluminium oxide. As per the rule, the element having lesser electronegativity should be written first, and you know the constant elements present in aluminium oxide are aluminium and oxygen. Since aluminium donates 3 electrons to attain stability, hence it becomes electropositive in nature. From the configuration, you can write the valency and write down them as subscripts. Similarly, you have to find the valency of oxygen from the configuration and write down them as subscripts. The second step is to interchange their valency. So you will get the valency of aluminium as 2 and that of oxygen is 3. There is no common numbers for dividing into a simplest ratio. Therefore, the chemical formula of aluminium oxide is Al2O3. Second example is carbon dioxide. So what are the constant elements present in carbon dioxide? Carbon and oxygen. So you have to find the valency of carbon and oxygen from its configuration. Don't need to write this configuration, it's only help you how you are getting the valency. Okay, so from this configuration you will get the valency and write down the valency as subscripts. The second step is to interchange their valency, so you will get the valency of carbon as 2 and that of oxygen is 4. Now, these two numbers are even numbers and it can be divided with a common number to get in a simple ratio. So divide with the 2, so you will get C1 and O2. If you are getting 1 as a number, don't need to write this number. So just write the element as carbon and oxygen O2. Is that clear? Now third example. Magnesium oxide. So here the constant elements present in magnesium oxide are magnesium and oxygen. And you know the valency of magnesium and oxygen from the configuration. Here magnesium donates 2 electrons and oxygen accepts 2 electrons. So magnesium is electropositive in nature and oxygen is electronegative in nature. Now interchange their valency. You will get Mg2O2. We can divide this number with a common number to get in a simple ratio. So divide with the 2. You will get Mg1O1. Remember, if you are getting 1, don't need to write this 1. You can write MgO. And the last compound is carbon tetrachloride. It's a very familiar compound and you have learned as an example in covalent compounds, right? You know the constant elements present in carbon tetrachloride are carbon and chlorine. Carbon share 4 electrons with a 4 chlorine atom. So carbon is considered as electropositive in nature and chlorine receives 1 electron from carbon and it becomes electronegative. So carbon is returned first with a 4 valency and chlorine adjacent to carbon with a 1 valency. Second step, interchange their valency, so you will get C1 and Cl4. So we can write the chemical formula as CCl4. Don't you seems to be an easy task? Okay, let's summarize the portions that we learned today. We learned about the valency. It is the number of electrons lost, gained or shared by an atom during the chemical reaction. Then we learned about the chemical formula, indicating the number of atoms in a molecule using symbols and the different way of writing chemical formula. Thank you.